So originally for this independent study, I wanted to explore the world of robotic prosthetics through the research done by U of M, as well as through a company called Clinic AI, who are completely reshaping the field of communication AI. Then COVID-19 happened. My contacts at U of M and Clinic AI unfortunately fell through, and I had to reevaluate. So my project took a big turn towards more of a building-based project rather than a research-based project. Huge thank you to my dad for becoming my sponsor and helping me throughout my entire project. So my main goal of this independent study was to program a 3D printed arm to grab an object and to recognize that object through AI. Throughout this independent study, I attempted to use several different things to accomplish this goal. In order to control the servos, which are powered and twist to make different parts of the robot move, I decided to use an Adafruit I2C driver. What's nice about this is that I can wire multiple of these boards together to power multiple servos at the same time. In order to control these servo controllers, you need a main board. I first used an NVIDIA Jetson to control them, however I ran into some issues running My Robot Lab. My Robot Lab is a program that will allow you to actuate the servos and run gestures, as you can see here when I briefly had it working with an Arduino.
Closing my right hand.
So to control the I2Cs, I chose to use a different board, the Raspberry Pi. I unfortunately had realized that within the time constraints, I would be unable to make the robot recognize the object and pick it up. So I kept on trying to get the robot to pick up the object. I spent a lot of time working with this, trying to get the Raspberry Pi to work. This is when I learned the importance of fuses and proper wiring. I ended up shorting out the Raspberry Pi, causing it to no longer be functional. I also blew a fuse. A fuse is a little piece of plastic and metal that will blow when you short circuit. If you don't use fuses, I've had it happen before where it will start smoking and actually melt the wires together. It was after this that I discovered that My Robot Lab does not work with a Raspberry Pi. So I discovered ROS, Robot Operating System, a program used by lots of major companies. This, however, does not work on the Raspberry Pi I had, so I went back to the NVIDIA Jetson. I installed all of the necessary software on the Jetson and resolved errors, and was finally able to put in values for servos and have the robot execute them to pick up a bottle. And here I have a demonstration of this, along with a few other objects I was able to pick up. Throughout this whole project, I've learned a lot, from Linux and Unix commands to soldering to proper wiring and fuses to installing a lot of software and assembling parts. Most of all, I learned how important it is to keep going. Despite all of the setbacks I've experienced with this project, from program switches to switching between different boards and installing a ton of software and resolving all of the errors that come with it, it all becomes worth it when it finally works. Even if it doesn't do everything you want, it still works, and that's completely what matters.